The question which I am going to discuss in today's session is going to give you a thrilling experience. It's a deadly combination of your freaking interest and my knowledge. The reason behind this is hidden in the question that is going to appear on the screen. I think you all must have seen Avengers Endgame. Oh, just see the excitement level on the name itself. Yes, today the question itself is going to give you an insight of Avengers Endgame and the three main characters. Number 1, Thor. Number 2, Captain America. And number 3, the very powerful Thanos. So here the question comes. Let us consider the iconic scene as shown in the figure where our beloved Captain America proves himself worthy enough to lift Thor's hammer, the Mjolnir. He is fighting Thanos at one end and giving his best to save the world. Adopt the following scenarios. So this is basically a kind of question that is asked in IIT BHU midterm examination of the subject mechanics of solids. So yeah, this is a 10 marks question which is having mostly 4 parts. In this particular video, we'll discuss the first 2 parts, and in the upcoming video, we'll discuss the next 2 parts. So here is the diagram associated with that. You can see in the figure, like we are having 2 figures. One is representing, yes, the Mjolnir, the Thor's hammer itself, which is thrown by Captain America towards Thanos to fight with him. And the second diagram basically shows the stress strain relationship. Oh my god, here comes the physics behind it. Here comes the actual solid mechanics, the stress strain curve. So let's jump into the question. So our first question says, our captain throws the hammer at Thanos with his might, with all his power. The total load applied here is 16 keeps. What is keeps? Have you ever seen such unit of load? I haven't. But I know what is keeps. I'll tell you in the later video. Consider the hammerhead to have circular cross section with diameter 7 by 8 inches. Find out the stress when this load is applied to throw the hammer, and what is the stress that is going to be developed at the handle of the hammer, which is having a diameter 5 by 8 inches. Check figure 1b, and the figure 1b is itself representing the hammer, which is having basically the diameter AB, DAB as 7 by 8 inch, diameter BC, DBC as 5 by 8 inch, and the P denotes the direction in which the particular load of 16 keeps is applied. So friends, in the first part of the question itself, we are asked to find the value of the stress that is going to be developed because of the application of this particular load by Captain America towards Thanos on the hammerhead and on the bar handle itself. So firstly, we have to note down the value of the load. So in the question, आप देख सकते हो the value of load, that is P, is given as 16 keeps. So what is keeps? यू माइट बी वंडरिंग दैट मैंने लोड की यूनिट न्यूटन सुनी है, किलो न्यूटन सुनी है, केजी फोर्स सुनी है. व्हाट इज दिस कीप्स? So keeps is basically another system of unit, FPS unit of force, and we have to convert into the SI unit. So keeps is nothing but it's kilo pounds force. Pound is a unit of weight, and pounds force is itself the unit of force, and kilo, that means 10 raised to power 3 is multiplied with that. So we can say that 1 keeps is equal to 1000 pounds force, क्योंकि 1 keeps 1 kilo pound force के बराबर है. So 1 kilo anything 1 kilo newton is 1000 newton, वैसे ही 1 kilo pound force is 1000 pounds force. Now we know that 1 pound is approximately equals to 0.4535 kgs. So we have converted this pounds into 0.4535 kgs, and this is kg, so we have to multiply with the value of g to convert this particular value of mass into newtons. So 0.4535 kg into 9.81, so this value will come in newtons. So now we are having 16 keeps. So 16 keeps will be equals to what? 16 into 1000 into this weight, 0.4535 into 9.81 Newton. You can take the value of G as 10 meter per second square as well in order to make the calculation easier. But to be more accurate, to be more precise, I am taking the value of G as 9.81 meter per second square. unless stated otherwise. So P is coming out to be equal to 71181.36 Newton. If you want, I can show it with the help of my calci as well. So we have to multiply like 16,000 into 0.4535 into 9.81. So you can see it's coming out to be exactly 71181.36 newtons. That is no near about, you can say, 71.181 kilonewtons. Fine. Now moving ahead, so firstly we will calculate the value of stress for the hammerhead. So we are having the diameter d of the hammerhead as 7.8 inch, as you can see in the figure B itself. So this is in inches, so we'll convert into millimeters, because ultimately stress को हम report करते हैं either in Newton per mm square, or that is also referred to as megapascal, or SI units kilonewton per meter square. So in solid mechanics we are more compatible with Newton per mm square or megapascal. So to do that we are converting the particular diameter into millimeters only. So 1 inch is equal to 2.54 centimeters. So 7 by 8 inch will be equal to 7 by 8 into 2.54 centimeter. This is in centimeter. To convert into millimeter, we have to multiply it by 10. So 7 by 8 into 2.54 into 10, that is approximately 22.225 millimeters. Now, coming to the most important thing, that is the stress calculation. So stress is simply load per unit cross sectional area. Load is capital P, cross sectional area, because in the question itself it's mentioned that you have to consider the hammerhead to be circular, which is having a diameter this much. So its area will be pi by 4 d square, that is a cross section area. So we will substitute all the values. P is this one, 71181.36. D is 22.225. When you will substitute all these values, you will get the value of stress as, let's use the calci and calculate. So how much we are getting? Okay, so 71181.36 into 4 divided by 3.14 divided by 22.225 divided by 22.225. So you can see it's coming out to be 183.574. So 183.57, let's make it as 5, round off, Newton per mm square, or 183.575 megapascals. Now we wish to calculate the value of this stress that is going to be developed at the hammer handle itself. So hammer handle is having a diameter of 5 by 8 inch. So we'll use the same particular formula, that stress is equal to load per unit area. Load will remain same. You will divide the cross section, so P this side, so balance with P that side also. So this is the area, pi by 4 d square. D is 15.875. We have to again convert into millimeters. When we'll calculate this particular value, you will get exactly, let's do 71181, you can see, 0.36 into 4 divided by 3.14 divided by 15.875 divided by 15.875. So it's 359.81. You can see that we are done with the stresses at the two particular handles and the hammerhead, and we are having the value of the stresses as 183.575 and 359.81 megapascals.